So, reconsidering the scientific view of a God, maybe not the God that you think of, but it's one that holds scientific water. That, according to our guest, Dr. Bernard Haisch, and his book, The God Theory. But the God Theory also includes zero-point fields. We'll get into that coming up next, and then the digital universe next, too, on Coast to Coast AM. This is Ian Punnett. Dr. Bernard Haisch, astrophysicist and the editor of many prestigious scientific journals, explain zero-point fields and how that relates to the God theory.
Well, this is a kind of a difficult subject because if you get online and you look up zero-point energy or zero-point fields, you find a lot of stuff, most of which is just silly. A lot of people have gotten very interested in this recently and written about it, and the problem is a lot of the writing about it is done by people who are maybe very well-intentioned but who don't know any physics. So there's mainly nonsense out there about zero-point fields and zero-point energy. But what it is in physics, actually, is the state of minimum energy of a quantum field. It has to do with light or radiation. And it gets a little bit technical, unfortunately. But the work I did in the mid-1990s, which was funded by NASA, had to do with trying to understand what caused matter to have the property of mass. Now, mass is the most fundamental property of matter. It's what keeps matter stable and solid. It's really kind of a definition of solidity and stability. And people have been looking for 40 years for a thing called the Higgs field to try to explain where that came from. That's sort of the number one priority of physics these days, to try to find this Higgs field that gives mass to matter. And what we proposed, again in the mid-1990s and are still working on today, is the idea that, well, you don't need a Higgs field. You have something right in front of our noses here that we've known about for years and years, almost 100 years, called the zero-point field. We've shown how that can possibly give rise to mass. Now, the interesting thing about that is, if in fact the mass comes from the zero-point field, not from a Higgs field, it opens the possibility that someday we might be able to control inertia, control mass, because it's basically, in a sense, kind of an electromagnetic phenomenon. And we know how to control electromagnetism. So in a nutshell, that was my interest in the zero-point field.
Well, I like that for the two different directions we can go from that. First of all, back to how does that relate to the God theory? And then secondly, if we could control it, what could we do with it?
Right. As it relates to the God theory, there was some speculation in the book, and that was all it was, because, in the esoteric traditions, you find a lot of references to light. Certainly you find that in Genesis. You go to Genesis, and it talks about the light being made on the first day. Then on the fourth day, the sun, the moon, the stars were created. Well, of course, that's silly, because the sun, moon, and the stars are the source of light. I mean, quite apart from the other problems with Genesis. But the order of things is clearly wrong. But it struck me one day when I found another book called the Haggadah, which is a book that didn't make it into the Bible, which had actually said, oh, there's another kind of light beyond the light made on the first day. And this light was concealed by God and will be discovered by the pious, and it gave some kind of reference, rather. It just occurred to me, my goodness, this is talking about something that sounds very much like the zero-point field, because here we have a form of quantum light that is invisible, so to speak. And it just kind of sparked my imagination that maybe there was a connection here between the reference to light in the esoteric traditions and the possibility that the zero-point field, which is a form of light, a form of radiation, a form of quantum light, that might be responsible for matter having mass. So it was that kind of speculation that went into the book. But beyond that, there's nothing deeper that I had to say about it, because I don't really see the zero-point field as being anything but a physical phenomenon. It's not God.
Right. Okay. And then if we could control it, what could we do with it?
Well, if we're correct, if matter gets its property of mass from the zero-point field, then that opens the possibility that you might be able to reduce the mass of something, change the mass of something, get rid of its inertia. If you get rid of its inertia, you can accelerate it instantaneously from zero to the speed of light in a fraction of a second. And that, of course, would be a very neat thing to do with respect to space travel. So there are profound implications if we're right about this theory. But, it's going to take some years to search for the Higgs field, especially with the new Large Hadron Collider coming online at CERN in Switzerland. It's going to take several years for people to look for the Higgs particle and not find it. And then if they don't find it, then maybe some interest will turn our way to the zero-point field as being the basis of mass.
Just out of a sense of fairness, by the way, the Haggadah, as you refer to it, the version that we have now actually probably was not written until after the Old Testament, as Christians would call it, was compiled. So it theoretically could have gone back and been included, but pretty much wasn't written until after that. Interesting, though, about the idea of the propulsion systems. Now, as you look at the possibility of an alien propulsion system, right? Even as a UFO skeptic, what might, if there are UFOs that are flying around within our atmosphere, and the way in which they are believed to move, would a kind of a propulsion system like that have to be necessary, or what else might they be able to employ? Just purely theoretically. I'm
intrigued by some of the reports I've heard, some first-person reports of the black triangles that have been seen for the last 20 or 30 years. And they've been reported to have the property that they're huge. They hover at very slow speeds, like 20, 30, 40 miles per hour. And then all of a sudden, boom, they vanish. They're not vanish into thin air, but they sort of accelerate instantaneously to some enormous velocity, and they're gone. Now, I've never seen one myself, and I'm not sure I put, belief, let's use that word again, belief in them, though I've heard reports from people who have actually seen them, apparently. But one of their properties, supposedly, I'm hedging all these bets here.
Right, I noticed that.
Yeah, hedging all these, is that they have this property of acceleration to enormous velocities in a fraction of a second, which, of course, would flatten anybody inside the craft, unless you're controlling inertia. So it opens the thought in my mind, well, if these things are real, if they are, then somehow they're controlling inertia. So maybe, just maybe, this theory that I had worked on for a number of years, again funded by NASA, might actually make some sense and might be pointing in the direction of some future technology for us.
Is that the quantum vacuum work you were doing?
Vacuum, yes. The zero-point field and quantum vacuum are essentially the same thing.
Okay. So the quantum vacuum theory, as you worked on it for NASA, was with the hope of doing what? Well,
first of all, it was with the hope of understanding where mass comes from, because that would be a huge scientific breakthrough if we understood mass without having to find the Higgs field. But then it opened up the possibility that if you control inertia because it's electromagnetic, then there are new technologies that become available. I mean, it's just it becomes really, really fascinating at that point. We're a long way from that.
Why?
Well, because we haven't really proven yet, beyond the mathematical analysis, that the zero-point field actually can give mass to matter. There are theoretical studies that I've published with colleagues that point in that direction, but it's not convincing until you do an experiment.
You've done some work with dark matter, and you, as I understand it, even is it wrong to say some controversial theories about dark matter?
No, I've actually never worked on dark matter.
Oh no? Okay, I thought you were.
You may be thinking of dark energy, which is a different thing.
Thank you. That's exactly what I'm talking about. Okay,
dark energy, it may be the same thing as zero-point energy.
Okay,
could be the same thing.
Explain, if it's not, what is it that is dark energy? How would you define dark energy?
Well, we really don't know what it is. All we know is that the universe is not just expanding. We've known that, of course, for decades, that the universe is expanding, called the Hubble expansion. We've discovered in the last, I'd say, 10, 12 years, that the universe is accelerating. In other words, the expansion is not slowing down, which you would expect. I mean, look at it this way. The universe is full of stuff, stars, galaxies, planets, that attract each other. So to have a universe that's expanding, you wouldn't be surprised if it were slowing down because of all the gravitational attraction. Well, it's not. It's expanding at a more and more rapid pace. The universe is being accelerated by something. The universe is experiencing anti-gravitation, and this anti-gravitation is being caused by dark energy. And that's about the extent of what we know of dark energy. It's there. We don't know what it is, but it's causing an acceleration of the universe. Now, the intriguing thing to me is that the zero-point field would have effectively the same consequence. They have very similar properties, and so it could be the same thing, except for the fact that if you look at how much zero-point energy the theory predicts there should be, it's enormous. In fact, it's so enormous it's crazy. So there's something wrong, and there's something clearly wrong here, and yet there's something very intriguing here as well. A connection between the zero-point field and acceleration of the universe is a very intriguing concept. It's both very wrong and very intriguing.
So this dark energy, we can't scientifically capture it. We can't measure it. We can only be able to detect it on the basis of